Explanation of the components and their interaction in the secure network design. The network design features multiple critical components that collectively ensure a secure, efficient, and high-performance infrastructure. At the core, the Internet Cloud serves as the entry point for external traffic into the corporate network. Two routers are used for redundancy and load balancing, ensuring efficient traffic routing and uninterrupted connectivity. If one router fails, the other seamlessly handles the traffic, maintaining constant network availability. Positioned between the external network and the internal network, the firewalls protect against unauthorized access and filter traffic based on predefined security rules. These firewalls also establish a demilitarized zone (DMZ), which houses public-facing services like the proxy server, web server, and email server. The proxy server facilitates secure internet access by masking internal IP addresses and caching frequently accessed content for faster browsing. The web server hosts external facing applications, while the email server handles all corporate communications. Inside the corporate network, the core switch ensures smooth data flow between various departmental switches, connecting departments such as finance, human resources, sales, IT, and production. Each department is segmented with its own departmental switch, enhancing security by isolating sensitive data. The DHCP server assigns IP addresses to devices dynamically, allowing seamless connectivity. One of the most secure features of the design is the air-gapped R&D network, isolated from the rest of the corporate network to protect sensitive research data from unauthorized access. Challenges with running the GVM scan. Unfortunately, we encountered difficulties in executing the GVM, that is the Greenbone Vulnerabilities Management Scan, a tool designed to identify vulnerabilities within the network. Despite several attempts, the scan failed to run successfully, potentially due to issues in the configuration of keys, components such as the OpenVIS scanner and the Greenbone Security Assistant (GSA). Another possible cause could be a failure in database initialization or difficulties with vulnerability feed synchronization, which are both essential for detecting up-to-date security threats. Without the scan, it becomes hard to access the network's security posture and identify potential weaknesses, such as outdated software or misconfiguration that could be exploited by attackers. The inability to execute the GVM scan highlights the critical need for a reliable vulnerability management process. Without regular scans, it is difficult to identify and address vulnerabilities in the network, leaving it exposed to potential risks. The failure to run the scan serves as a reminder of the importance of thoroughly testing and configuring vulnerability management tools before they are deployed. Regular scans are an essential part of maintaining a secure network, as they allow organizations to detect emerging threats and apply necessary patches before any damage can occur. Resolving these issues with the GVM configuration will enable a more proactive and effective security strategy moving forward. Security issues and implications of advanced and novel network and protocols. As new technologies like 5G, software-defined network (SDN), and cloud computing continue to be adopted, they introduce new security challenges that require careful consideration. 5G networks provide faster speeds and greater connectivity, but they also increase the number of devices connected to the network, expanding the attack surface. The introduction of new IoT protocols designed to support these devices may have insufficient security, making them vulnerable to attacks, like botnet attacks, where compromised devices are used to launch coordinated cyber attacks. The higher density of devices in 5G network means more potential targets for cybercriminals to exploit. Software-defined networks (SDN) offers centralized control of network, providing flexibility and scalability. However, it also introduces the risk of a single point of failure. If the SDN controller is compromised, attackers could gain control over the entire network. This centralization increases the vulnerability of the system, making it an attractive target for cyber attacks. Similarly, cloud computing introduces security concerns related to virtualization. The reliance on virtual machines and hypervisors increase the risk of attacks targeting the underlying infrastructure. Since cloud services are hosted on the internet, they are exposed to external threats, making it essential for organizations to implement robust security measures like encryption and regular vulnerability assessment to protect data stored in the cloud. Explanation of the